partial fractions. So before we look at what partial fractions are, let's just consider the following integral. We have the integral of 5x plus 1 all over x squared plus x minus 2 dx. And finding this integral is going to be quite challenging because we don't have any real rules here to help us evaluate this integral. But this is actually equivalent to the integral of 3 over x plus 2 plus 2 over x minus 1 dx. And this here is much easier to evaluate now because we can do the integral of these fractions separately. And this is what partial fractions is all about. It's about taking a fraction and decomposing it into more manageable fractions. And we're always going to be able to do this based on the theorem that if we have some polynomial p of x over a of x multiplied by b of x, we'll always be able to break it down and decompose it into its partial fractions if the degree of p of x is less than the degree of a of x plus the degree of b of x. And in this case, the degree of p of x is the highest power in the polynomial here of the numerator, which is 1. And the degree of a of x is this part here, the highest power here, which is 1, plus the highest power in this denominator, which is also 1. And we get 1 is less than 2, so we know this is going to work out. And if we have some polynomial p of x over a of x times b of x, we'll be able to write it as some polynomial ra of x over a of x plus some other polynomial, let's call it rb of x over b of x. And here, the degree of r of x has to be less than the degree of a of x, and the degree of rb of x has to be less than the degree of b of x. So in this case here, the degree of this is 1, so this has to be a constant, and same over here. So let's have a look at an example on how we can go about doing this. So if we have some fraction x plus 1 all over x minus 1 times x plus 3, how can we rewrite it in terms of its partial fractions? Well, we know we're going to have some constant over our first polynomial, x minus 1, plus some other constant, because it's linear, over our next polynomial, x plus 3. And all we have to do now is solve for a and b. So what we want to do is multiply everything by this denominator. That's just going to leave us with x plus 1 on the left. Multiplying this term by this denominator, the x minus 1s will cancel out, and we'll just be left with a multiplied by x plus 3. And then over here, something similar, we're left with b multiplied by x minus 1. Let's go ahead and expand our right-hand side. We get ax plus 3a plus bx minus b. Let's collect x's together and constants together, and we'll factorize out the x at the same time. So we'll get a plus b all times x plus 3a minus b. And now we can just go ahead and equate coefficients. So if x plus 1 has to equal all this, a plus b must equal the coefficient of x, which is just 1. So we're going to get a plus b has to equal 1. and we also get 3a minus b has to equal 1 as well for that constant term. And all we have to do here is solve simultaneously. So let's add these two equations together and we'll get 4a equals 2. So a equals a half. And we can go ahead and sub that in to any equation. So we can go ahead and sub it in here. So that's going to give us b also equals a half as well. Which means that this fraction, we now can write in its partial fractions because we know the values of a and b. So our final fraction is all going to be equal to a half over x minus 1 plus a half over x plus 3. You could even add those fractions together and see if it equals that, which it will. And we're not actually going to do the integral of this fraction, but we're just learning how to decompose our fraction into its partial fractions. So let's look at another example. Let's look at x cubed plus x minus 3 over x squared minus 3x plus 2. So here we have a situation where the degree of the numerator is actually higher than the degree of the denominator. So it's not going to work as it did before. But this time, if the degree is greater than or equal to, we need to do the following method. So even if it was a squared, it'd be equal to it, and we'd have to do this method. So we're going to do this when it's the numerator's degree is greater than or equal to the denominator's. Well, it's going to be similar. We're going to get, it's going to write it as c over some factor plus d over some factor. But we're also going to have to add in a polynomial as well. So we're going to have ax plus b as well. So we've got 4 unknowns to find here. So what are these factors though? Well, all we have to do is just factorize the denominator in here to know what our factors are. So we can factorize that as x minus 2 and x minus 1. So we know what our factors are. Now we just again have to multiply out by our denominator and solve for a, b, c, and d this time. So multiplying every term by our denominator is just going to leave us with our numerator, x cubed plus x minus 3. Ax is going to have to be multiplied by x minus 2 and x minus 1, our denominator. So is b, x minus 2 and x minus 1. C will just be times by x minus 1, and d will be times by x minus 2. So let's go ahead and expand the right-hand side. So we're going to get x times x is x squared, times the ax is ax cubed. X times minus 1 is minus x. Minus 2 times x is minus 2x, so we get minus 3x times the a is minus 3ax squared. Minus 2 times minus 1 is 2 times the ax is plus 2ax. Multiplying x and x, we get x squared, times b, we get plus bx squared. X times minus 1, and the minus 2 times x gives us minus 3x, times b is minus 3bx. Minus 2 times minus 1 is 2, times it by b, we get plus 2b. Expand out the c, we get plus cx, minus c, plus dx, minus 2d. Now we've got to group our cubes, squares, and x's and constants together. So there's only one x cubed term. So we've got two x squared terms. So we'll write plus x squared and then we'll factorize. So we've got the b and the minus 3a. The x terms, we'll factorize and group at the same time. So we've got 2a minus 3b plus c plus d. And our constant terms, we've got 2b minus c minus 2d. And we've still got it equal to x cubed plus x minus 3. And now we can just equate the coefficients. So we'd have a equals 1, b minus 3a. Well, there's no x squared term, so it's all got to equal 0. We've got 2a minus 3b plus c plus d has to equal 1, match up with the coefficient of x. And 2b minus c minus 2d is going to have to equal minus 3 to match up with the constant. And now let's go ahead and solve for all four of these. Well, we've already got a equals 1, and we can sub that into our next equation here. So we'll get b minus 3 times 1, which is just minus 3, equals 0. So b has to equal 3. Now, we can just use these two equations now to solve for c and d. So we've got 2 times a, which we know is 2, minus 3 times 3, which is minus 9, plus c plus d equals 1. We can tidy this up. 2 minus 9 is minus 7, and taking to the other side, we're going to get c plus d equals 8. Our other equation, we've got 2 times b, which we know b is equal to 3, so we get 6, minus c minus 2d equals minus 3. Take the minus 6 to the other side, and we get minus 9. Just divide everything by the negative. Actually, we don't know how to do that. We'll just add the two equations together. Then the c's will cancel out, and d minus 2d is minus d, and 8 minus 9 is minus 1, and that means d is equal to 1. And we can sub that into any equation we like. We can do this one, and we'll get c plus 1 equals 8, so c has to equal 7. And now we've got everything we need to rewrite this fraction a lot easier. So this fraction must equal a, which we know is 1, so just 1x, plus b, which we know is 3, plus c, which we know is 7, over x minus 2, plus d, which we know is 1, over x minus 1. And integrating this will be a lot easier than integrating this. So let's have a look at another scenario where we have quadratic factors in the denominator. So let's have a look at 3x plus 10 all over x minus 2 times x squared plus 4. So we've also got to make sure that the fraction can't be reduced any further. So these factors are non-reducible. And when we have a quadratic factor in our denominator, its numerator term when we reduce to partial fractions needs to be linear. So we know that we're going to get something like this. We're going to get some polynomial over x minus 2 plus, let's write our denominator first, x squared plus 4, which is a quadratic. So we need a linear term in our numerator, so we get something like bx plus c. And here we can go about solving in the same way. So timesing everything by our denominator will just leave us with our numerator on the left. And we'll have a times x squared plus 4 plus bx plus c, all being multiplied by x minus 2. Now, we can expand and equate the coefficients. There is another way to work out what a, b, and c are as well. And that's by letting x equal something clever. And in this case, if we can let x equal to 2, we'll get 2 minus 2, which is 0, and it will cancel out this whole term here. So let's go ahead and see what happens when we let x equals 2. We're going to let x equal 2. So on the left-hand side, we're going to get 3 times 2, which is 6, plus 10 is 16. We'll get a times 2 squared, which is 2, plus 4, which is 8. And then, obviously, letting x equal 2 here will make this all 0, as this is going to equal 0. And you can see very quickly, just by letting x equal 2, we get a is equal to 2 as an answer. Over here, it makes it a bit tricky to let x equal something to equal 2, because we need x squared term to be minus 4, but that's not going to happen. So to work out b and c, we could try some other smart strategies. For example, letting x equal 0 will cancel out this b term, and we already know a. So let's go ahead and do that. So let's let x equals 0. So on the left-hand side, we'll get just 10. We know a is equal to 2. We're going to make x equals 0, so 0 squared is 0 times 4, plus the x equaling 0 will cancel out with the b, so we'll just have c, and x equals 0 will leave us with minus 2, so we'll just get 10 equals 8 minus 2c, so we get minus 2c equals 2, so c equals minus 1. And now we just need a value for b, and to do that, we're going to we can use anything really. So we'll pick something easy because we only need one more value here. We only need b, so we can let x be anything we want. So we'll just pick something easy to sub in. So letting x equal 1. So we'll get 3 times 1, which is 3, plus 10, which is 13 on the left. We'll get a, we know, is 2. Letting x equal 1 here, we get 1 squared, which is 1 plus 4 is 5. Plus b, we don't know. X is equal to 1, so we just get b there. Plus c, which we know is minus 1. And letting x equal 1, 1 minus 2 is minus 1. So we get 13 equals 10. Expanding that minus, we'll get minus b plus 1. So we get 13 equals 11 minus b. So we're going to get minus b is equal to 2. So b has to equal to minus 2. And now we have everything we need to rewrite our fraction as a partial fraction. So now a is equal to 2 over x minus 2 plus minus 2x as b equals minus 2 minus 1 for c all over x squared plus 4. And again, this is going to be a lot easier to integrate than this fraction over here. Let's have a look at one more scenario. Going to look at the fraction 8 minus x all over x minus 2 squared times x plus 1. And here we've actually got a repeated factor in our denominator. So we've got this factor being squared, this polynomial being squared. And if we have this situation, the way we're going to break down our partial fractions is we're going to have a over the factor itself, x minus 2, plus b over x minus 2 squared. So we're building up towards our factors. So if we had x minus 2 cubed, we need another term, but we don't, plus c over our other factor, x plus 1. And from here, it's a similar process. We need to multiply everything by our denominator. So on the left, we're left with 8 minus x. On the right, we're left with a times one of the x minus 2's and the x plus 1, plus b times x plus 1, plus c times x minus 2 squared. And in a very similar way, we could let x equal some clever things here. So first we'll let x equal minus 1. If you do that here, this term will be 0 and this term will be 0, so this will find our value for c. And if you were to do that, c would equal 1. Then we're going to let x equal to 2, so something else clever, where this term will be 0, this term will be 0, and this will let us find b. And if we do that, we're going to get b is equal to 2. And finally, you can let x equal anything you want to just solve for that last variable. And if we let x equal 3, you'll find that a is equal to minus 1. And again, we have everything we need to rewrite this fraction. We know a is equal to minus 1 over x minus 2 plus b is equal to 2 over x minus 2 all squared plus c, which is 1 over x plus 1. And again, this is much easier to integrate than the original fraction.